Welcome to the TOEFL Listening section. In this part, you will hear one or more conversations in an academic or campus context, such as a discussion between a student and a professor or between two students. You may take notes while listening. Listen to part of a conversation. You will hear it only once, so listen carefully. After the conversation, you will answer questions about what you heard. Some questions will ask you about main ideas and details. Others will ask about implied meaning, speaker attitude, or how ideas relate to one another. Use both what is stated and what is implied to answer.
Good afternoon, Professor Morales. Thank you for meeting me during office hours to talk about my thesis on digital archive preservation.
Good afternoon, James. I read your proposal and I wanted to discuss some practical preservation strategies and examples you might include. Where are you with your literature review and your proposed preservation workflow?
I have summarized theoretical frameworks like OAIS and digital curation lifecycle models, but I feel uncertain about concrete steps such as migration timing, metadata standards, and how to prove long-term integrity.
Those are central issues. Start by outlining a preservation policy that defines responsibilities, designated community, and acceptable risk. Then choose technical safeguards like Fixity Checking, replication, format normalization, and when necessary, emulation.
When you say Fixity Checking, what exactly do you mean in operational terms for an institutional repository?
Fixity Checking means calculating checksums for each file, and then periodically recalculating and comparing them. That detects bit-level corruption, or bit rot. It is part of a preservation plan to ensure content integrity over time.
Which checksum algorithm would you recommend? I read about MD5 and SHA variants. My initial plan listed MD5 because older scripts use it.
I would advise SHA 256 or a stronger algorithm. MD5 has known collision vulnerabilities and is no longer recommended for long-term preservation. Also record the algorithm in metadata so future audits know how checksums were produced.
That makes sense. How should checksums and fixity events be documented so they are useful to auditors and future staff?
Use a preservation metadata standard like PREMIS to record events and agents related to fixity checks. Store packaging metadata with METS and descriptive metadata with Dublin Core or a richer schema. PREMIS captures fixity events, who ran them, and the checksum algorithm.
So we use M8s to bundle files and PREMIS to log preservation actions. I noticed some repositories also mention audit frameworks. How do those fit in?
Audit frameworks like TRAC or the ISO 16363 standard provide criteria for trustworthy digital repositories. They look at organizational policies, technical infrastructure, and transparency. If you design your workflow to generate audit evidence, passing an audit becomes feasible.
Could you give an example of a real-world project that implemented these practices? A case study would help my thesis readers.
Certainly. At our state university, we digitized a large photographic collection. We normalized master images to uncompressed TIFF, generated SHA 256 checksums, stored PREMIS events, and kept 3 geographically dispersed copies. For web content, we used WARC files and Archive-It. The repository also migrated obsolete formats like WordPerfect into PDFA and documented the migration with PREMIS events.
You mentioned migrating WordPerfect files. Migration can be lossy. How did you justify changing original formats?
We used a risk-based approach. If the original format was at high risk of obsolescence and readable only by unsupported software, we normalized to a preservation-friendly format that retained essential content and structure. We kept the original files as bit streams when possible and recorded technical metadata and migration events so researchers can see what changed.
What about software-dependent objects like interactive data visualizations or obsolete multimedia? Migration may not be possible.
Exactly. For those we considered emulation. Emulation replicates the original environment, so the object behaves as intended. Emulation is resource-intensive, but for culturally significant or research-critical items, it is a valid preservation strategy.
Do repositories still use tapes like LTO, or do they prefer cloud storage today?
Many repositories use a hybrid approach. LTO tape is cost-effective for cold storage and has longevity when refreshed. Cloud storage offers replication and geographic distribution, but you must evaluate vendor lock-in, access costs, and encryption. Combining local disk, tape, and cloud replication reduces single points of failure.
How frequently should a repository run fixity checks and refresh storage copies?
That depends on risk assessment. For active collections, monthly checks are common. For less active or very large collections, quarterly or semi-annually might suffice. Important is to log the schedule and the results in PREMIS so you can demonstrate ongoing stewardship.
We run automated fixity checks monthly and record checksums in PREMIS metadata to detect bit rot before it spreads.
Good phrasing. Also consider replication policies. Keep at least 3 copies, ideally in different administrative domains. LOCKSS and CLOCKSS are examples of distributed dark archive systems for scholarly content.
What about persistent identifiers? Should every preserved file get a DOI?
Not every file needs a DOI. Use persistent identifiers judiciously for collections or significant objects. Arcs or handles can be used at object level. The key is to ensure that identifiers are resolvable, managed, and linked to preservation metadata so provenance is clear.
For my thesis, I want to include a sample preservation plan. What elements should be mandatory?
Include scope, designated community, accepted formats, metadata schema, fixity and replication schedule, format monitoring and migration triggers, disaster recovery, roles and responsibilities, and audit readiness steps. Add a cost model that accounts for storage, staff, and periodic migrations.
I will draft that. Finally, are there tools or open-source platforms you recommend for small institutional repositories?
DSpace and Fedora Commons are widely used and have preservation-oriented workflows. Archivematica is a robust open-source ingestion and preservation tool that implements METS and PREMIS. For web archiving, use Heritrix and WARC packaging. Combine these tools with a policy and audit focus.
Thank you. This gives me concrete steps and examples to include. I will update the thesis with PREMIS examples, our case study, and a scheduled fixity plan using SHA 256.
Excellent. Bring your revised chapter next week, and we can review how the plan maps to ISO 16363 audit requirements. Also include an example of a migration event recorded in PREMIS for clarity.
I will. Thanks again for the guidance, Professor Morales.
You are welcome, James. Good luck with the revisions.
Listen again to part of the conversation. Then answer the question.
We run automated Fixity checks monthly and record checksums in PREMIS metadata to detect bit rot before it spreads.
This concludes the conversation portion. For more TOEFL practice tests and study materials, visit Spinta.org.